Hey everyone, so we've got this incredible paradox in AI right now. Large language models, they're brilliant, right? They can write code, they can reason, but if you give them a really long, complex task, they just fall apart. So how do you get around that? Well, that's what we're digging into today.
Let's just start with a huge question, something that feels like science fiction. Right now, today, could an AI actually build something as incredibly complex as a skyscraper?
And the blunt answer is no way. Not if it makes one tiny mistake on step 101 out of a million different steps. See, a single error, just one, can bring the entire project crashing down. And that is the absolute core of the AI reliability challenge.
And that right there is what's known as the AI reliability problem. The whole issue is that when you're dealing with these massive, multi-step projects, having a 99% success rate, it's just not going to cut it. Okay, to really get this, we have to talk about one key idea from the research that inspired this whole thing, the per-step error rate. It's pretty simple, really. It's just the chance that an AI is going to make a mistake on any single step in a really long chain of tasks.
Now, imagine we have an AI with a 99% per-step success rate. I mean, that sounds amazing, right? It's almost perfect. But just watch what happens when you start stringing those steps together. After only 10 steps in a row, the chance of getting a perfect, error-free result has already dropped to 90%. And believe me, the drop-off gets way, way steeper from here.
By the time you hit 100 steps, your chance of success has absolutely plummeted to just 36%. That's that step 101 failure we were just talking about. At this point, it's actually more likely that your project has already failed than succeeded.
And by the time we get to 500 steps, it's basically game over. The chance of a perfect run is less than 1%. So trying to solve a million-step problem this way, it's not just hard, it's statistically impossible. The odds just round down to zero.
Okay, so if just building a bigger, smarter AI that makes fewer mistakes isn't the solution, what on earth is? Well, the paper we're looking at proposes this radical, totally counterintuitive idea. Smash the intelligence into tiny, tiny little pieces.
And this right here is the big aha moment. The researchers are saying, look, instead of trying to build a bigger brain, let's build a better system. They call it massively decomposed agentic processes, which is a mouthful, I know. But it just means instead of one super smart AI, you use a whole team of smaller, simpler AIs to get the job done.
So how do they actually do this? Well, they developed a system called the Maker method. And it's all built on three really simple but really powerful ideas: decompose, vote, and flag.
So here's the breakdown. First up, maximal decomposition. You take a huge, complicated task and you break it down into the absolute smallest possible microsteps. Next, error correction by voting. For every single one of those little steps, you have several different AIs solve it on their own, and then they all vote on the right answer. It's a fantastic way to weed out random mistakes. And finally, red flagging. Any response from an AI that just looks weird or is formatted wrong gets thrown out immediately. The researchers found this is a super strong signal that the AI is getting confused and is probably about to go off the rails.
Okay, so that all sounds pretty great in theory, but the real question is, does it actually work in practice? And this is where the story gets really cool. The researchers put Maker through the ultimate test, a classic problem that requires over 1 million steps to be solved perfectly.
And they didn't pick something easy. The challenge they chose was the legendary Towers of Hanoi puzzle. But they didn't just use a few disks. No, they used 20 of them. This isn't just a simple game. It's the perfect test for long-range, step-by-step reasoning.
Solving this 20-disc puzzle requires a truly mind-boggling number of perfect back-to-back steps. So how many are we talking about? Get ready for this. Over 1 million. 1,048,575 steps to be exact. And the number of errors? The number of times the Maker system messed up across that entire million-plus step process? Zero. Absolutely zero. A perfect run. I mean, this is a huge achievement. It demonstrates a whole new level of reliability for AI.
And just take a look at this. This is a snapshot from the paper showing the system about halfway through the problem. It really helps you visualize the massive scale of this operation. Each little segment you see is a step, a tiny task for one of those micro-agents. The green parts are done, the blue parts are still to go. You're literally looking at a system of organized intelligence at work.
So what does a stunning result like this really mean for the future of AI? Well, it suggests that maybe, just maybe, we've been thinking about how to scale AI in a really limited way. It seems the future might be decomposed.
You're basically looking at two totally different paths forward.
The old way, what we can call scaling intelligence, is really a brute force approach. Just build bigger models, throw more data at them, spend more money, and you still get these persistent errors. But the new way, scaling process, is about building smarter systems out of these decomposed tasks, and that leads to way higher reliability, probably at a much lower cost. It's a complete paradigm shift.
So why should you care about this? Well, think about it. This means we could finally have AI that can reliably manage incredibly complex things. We're talking global supply chains, building entire software projects from scratch, or running long, complicated scientific experiments. It also gives us a path to safer AI, because you're limiting the power of any one agent. And we can do all of this using smaller, cheaper, and more efficient models. And that leaves us with this one last, really fascinating question to chew on. Is the next great leap in artificial intelligence going to be a single, giant, all-powerful mind? Or is it going to look more like a perfectly organized society of smaller, specialized agents, all working together in perfect harmony?